Okay, so how do we approach a quadratic? Do we try the zero product property first? Do we try the square root property first? There's a few answers, but here's what I would do. To me, it's easier to look for that situation. Do I have a perfect square? And over here, there is a square, but I've got other x terms, and this is not a perfect square. And so I don't have this situation. I could factor that, but that's not a perfect square. And if I do factor it, I'm not going to have 0 on the other side. I would have -2. All right, so this does not work. Okay. So because that is pretty easy to spot, that's something that I would look for first. If that doesn't work, if it's not obviously fitting a candidate for the square root property, then I would see if it can be factored. Can it be turned into a times b equals 0? Can I factor it? And so the nice thing about the factoring by grouping method that I showed you is you can also very easily see if something can be factored. Alright, so here I multiply 1 and 2, that's 2. Okay, I'm looking for two factors of 2 that add up to -4, and immediately you should think, no, that doesn't work. There are no factors there is no pair of factors of 2 that add up to -4. Okay, so we know that this actually cannot be factored. And that's the other nice thing about the factoring by grouping. You don't have to work through a bunch of trial and error to realize, this one cannot be factored. Well, then what do we do? Can't be factored. It doesn't seem to fit the square root property. Well, we have a way to basically turn it into something that is a candidate for the square root property, and that is called completing the square. And this is kind of the third method, which really is, I suppose it could be a subset of using the square root property, which it is. Only it takes some transformation in order to get it into that form. And so that is this process of completing the square. And here's how that works. So anytime we've got an x squared term, right, we can represent that visually with a square, x by x, right? So this has an area of x times x, right, length times width, and it is a square, so the area is x squared. And then that minus 4x, right, basically any number times x, I could represent as a rectangle with one side, which is x, right, it's the same as that square, and then this side, I know we usually don't use negatives for lengths, but go with me. We'll use the same logic can apply. So so this would be -4 times x, my length times my width. Okay, but now it's a rectangle. It's not a square. So how do we complete this square? Well, first, because remember, I mentioned this in another video, but the nice thing about equations is I can add anything I want as long as I add the same thing to both sides. Now, if I want it to look like this, if I add x squareds or if I add x's to both sides, I'm really just making it more complicated because I'll have to move the x back. So that doesn't help me. But if I add a number, right, because if I'm going for this, I don't necessarily need that to be 0. It could be a number. And if I can add a number to both sides, that will make this a perfect square. right? Because I could add any sort of number over here and turn this into something that I could factor. But then I'd have a number over here, and this, right? I can't use the zero product property on this. I can't draw any conclusions from a times b equals 3. Right? It could be 6 and 1/2. It could be 1 and 3. I can't draw firm conclusions that way. Right? So that's why it's a zero product property, not the 3 product property. All right, but if I can add a number that makes this not just factored, but a perfect square, then it doesn't matter if this is a number because I can take the square root of both sides, huh? All right, so how do we make this a perfect square? Well, I don't want to change the negative 4x, but I can add numbers. So what I'm going to do is I'm going to cut this in half. And I'm going to move it over to this side. Okay, so now this is x by, not negative 4, but negative 2. And I just simply move this other piece, I'll scribble it out, because I'm going to move it over here. Okay, now there's my other negative 2 by x, and those add up to negative 4x. So now it's almost a square, right, because this side is the same, x and negative 2, as this side, x and negative 2. It would almost be a square, except for the fact that, oh, look at that. I'm missing that little corner. Well, how big is that corner? Oh, it's negative 2 by negative 2. And next time I'll pick a positive example, so it's not this weird. But negative 2 times negative 2, oh, that's a number. That's 4. What I need is for this to be a 4, and that would be a perfect square, because x minus 2 times x minus 2, oops, you can't see that, is x squared minus 2x minus another 2x plus 4. See that? I'm just off by 2. So if I add 2 to both sides, now I've got x squared minus 4x plus 4, which is a perfect square, is equal to a number, or x minus 2 squared, because that's what that is equal to, is equal to 2, and now I can solve it with the square root property. Oh, check that out. So now I've got x minus 2 equals plus or minus root 2, and add 2 to both sides, I've got my answer on something that I couldn't factor, and that didn't immediately look like that, but through some logical reasoning, I can add a number that turns this into a perfect square, and then it doesn't matter if I've got a number on the other side because I've got the tool to deal with it. Yay! Completing the square. So this will save for the next video.